and for a wonderful presentation. I think all of us agree upon the great, I think, common values you have in ProPASS and in your society about being open, integration between different fields and topics. Just, at least I have really felt it every time I have participated in ICAPAM and look forward to them. Unfortunately, we are over time, so we don't have time for questions, but please post them in the link, and then I'll forward it to Alan if you have any. So thank you, Alan. Then I give the word further to the chair, Richard Pulsford.
Thank you, Andreas. Okay, everyone, we're now going to move on to our keynote session for this year's conference. And given the focus of this year's meeting, and particularly on this second day where we're looking towards the future of wearables research, we're absolutely delighted that for our keynote session this year, we're joined by Professor Rob Harle. So Rob is a professor in the computer science department at Cambridge and a research scientist in Fitbit within Google. Rob's research interests are related to mobile systems with a focus on sensor algorithms. And this started with location tracking, but shifted to health and well-being, especially preventative health via physical activity. Within Google, his team focuses on novel sensor algorithms for Fitbit wearables, most recently having released new heart rate algorithms based on deep neural nets that are significantly more accurate than previous generations. So we're really excited to hear Rob's perspective on the opportunities and challenges within this wearable space. So with that, I'll hand over to Rob. Over to you, Rob.
Thank you very much, Richard. Can I just confirm you can hear me and you can see my slides?
Yes.
Awesome. Okay, so let's get going. So yeah, Richard rather foolishly gave me the option of just talking about anything I wanted to talk about here. So I'm going to talk about one of my current passions, which is around bringing together industry and academia for doing all the sort of stuff that we're talking about in this conference. And I didn't used to think this, but ultimately we're all in the business of behavior change. Someone said this to me recently, and I thought, no, I develop algorithms, and I publish stuff that's around the effect it has. The reality is it is always about behavior change because we want to get better health outcomes, whether we're trying to find something that is some new discovery or some new device. It's all in service of trying to change people's behavior and make them better for their health. And we, of course, as a group, focus on physical activity and sleep because, well, it's easily modifiable, at least compared to the other things that you'd have to modify. And we know they actually move the needle in terms of your health, unlike other things which you might not know about or just don't move it very much. And the problem, and I'm fully aware that I'm telling everyone on this call something they already know. The problem with this, all the signals that we're talking about here are, it's all highly complex. It's very multivariate. Everything interrelates. And a tiny little change can be significant, and a major change can be a total confounder. So you might observe someone who is walking differently for 2 weeks, and you might decide that's a major health sign, that's something that they need to take action on. Or it might just be that it's been snowing, and for 2 weeks they've had to walk differently. So it's very difficult to deal with all of this large-scale data. And on top of that, we only ever have a small window into what's actually happening. We only have a tiny accelerometer on the wrist or on the thigh or whatever it is. That's all we have. We don't have all of the information that we would quite like. And so, having spent a bit of time in academia and a bit of time now in industry, I've formed this view that we really need to find some way of fusing the commercial and the academic worlds together so that we can progress faster in this mission. I see advantages in both sides of this. So industry is kind of providing all these consumer devices, and a lot of this talk will discuss why consumer devices are good and actually why consumer devices are bad for the things that we're talking about. You see better tooling in industry, and you see a large ecosystem, which, as was alluded to in the previous talk, we somehow need to find a way of getting access to. From an academic standpoint, you see research devices, which provide their other benefits. You see health measures, which typically industry doesn't have. So it doesn't have your health record. It's hard to match back to what's actually happening and what does happen. And the epidemiology skills that you find in industry are quite weak compared to what you see in academia. And so I'm going to spend a bit of time talking about consumer devices. And what do I mean by a consumer device? Well, technically, I suppose I mean anything that is something you can buy off the shelf that is being sold for purposes of commercial validation. However, the reality today is that it's really only watch, buds, and other consumer devices. Yes, they exist in small quantities, but they're generally not going to have the same properties of the stuff that I'm talking about here. So for today, it's mostly about watch, buds, and phone. And the reality is it's mostly about watch for the things that we are interested in. Okay, so I'm going to spend a bit of time talking about these devices and what I've learned from the other side of the void, as it were, from industry. So today we obviously we as academics would deploy research-grade devices, large numbers of people, biobank, ProPASS, you name it. There's a lot of this, and of course, many of you will recognize the activity device. And there's lots of pros to this. You always get exactly what you want, or if you don't get exactly what you want, then you can make one that does. You typically have a good battery life. They're usually quite small and light. They are single purpose, and that's a good thing in the sense that usually things that are single purpose or focus on that purpose are better at doing that thing. And you get some raw data, although I'm going to be spending a lot of time on that raw data in this talk. There are quite a few cons, though. We all know that funding will dictate the capabilities. It tells you what you can buy. You can't buy that one with a gyro, but you can buy more of them if you just have that little accelerometer in there. And it also dictates the scale at which you can push these things out. These devices are not especially desirable, so you're relying on the participant being willing to contribute to research. They don't want to wear that device for any other reason. They're just being good, if you like. Now, the problem, of course, is that you will get poor adherence when this happens. So it's fine to do a test for a week or two. People will wear it. But when you start saying months and years, they're not going to wear this device because it doesn't really give them much benefit in the first place. Some of these devices are not especially robust, and you need to have support of the devices and mechanisms to get all of that data back and stored. The number of times I've spoken to academics who are relying on post. You have to post the devices back. We're going to connect the cable and we're going to download all this data. Maybe that's okay for 10, maybe that's okay for 40, but when you get to 1 million, it's not okay. Something that the previous speaker alluded to was interaction possibilities. You don't really get these on research devices in general. That's the ability to send alerts, etc., and to be part of an intervention. Now, I said you get raw data as a pro, but actually you only get raw data, and that's a con. And I'm going to explain why it's a con. So what are we doing? I'm trying to argue that for some things, not all the time, we would want to go from a research device, and there's value in using these consumer devices, these things that have been built and they're sold on the shelves. You might well be asking, would this actually be a good idea? I think there's a number of advantages in this. One is it's designed to be very attractive. It's something that people are supposed to buy. And this will really help adherence because if it's serving a purpose, if it's something they want to wear because it does something in their lives, they will wear it for years. You will be able to get all of that data for a long period of time. They're always built to be robust, or at least reasonably robust, and they are heavily factory tested. It's not usually true of your research devices. They will be waterproof, etc., etc. A big thing for us, I think, is it exists in an ecosystem that provides what I call organic scale. We'll talk about that a little bit more later. There's commercial software with support, and we get some feedback to the user from the ecosystem. So that's quite nice. One thing we found is that we don't actually have to spend all our time coming up with, oh, we're giving you feedback to keep you interested in this research project, because actually they're using the device anyway, and they're just using the normal features of the device, and the ecosystem is providing value to them. So they want to keep wearing them. We get secure data transmission. Do not underestimate that. And you theoretically get professionally developed and tested algorithms. And that's the one that I want to really focus on because that's one of the biggest surprises I got when I came from academia to industry. So let's talk about this a little bit. Here was my perspective when I first joined Google about 5 years ago. I thought, well, I want to do research, and the only thing I care about really is raw signals. I don't want to know any of these other algorithms that have been run. I just want to know the raw signals so I can do everything myself and get really great results. So in the case of a watch, PPG, accelerometer, gyro, that's what I thought I wanted. There's derived quantities that are produced that I thought I didn't want: heart rate, sleep stages, activity level, etc. Obviously, I wanted to get to those points, but I didn't want them given to me in the device because I didn't trust them. And now let's talk a bit about some practicalities for this then. So raw data has 3 problems, I guess, when you have a consumer device. One is you're going to get reduced battery life. One is that you're going to need more storage. These are both very obvious. And there is also another really obvious one, which is that raw data isn't always available to researchers. That's something I and others in industry are now trying to change, but it is just simply the case that sometimes you cannot get the raw data from a sensor. Now, let's imagine that you do get raw data from your devices, whether it's a research device or a commercial device. How sure are you that your processing algorithms work well on diverse free living populations? So I refer back to my previous comment. I used to think, well, I want to control the algorithm. I want to know everything about this. I want to take the best thing I can find in literature and apply it. And that's the thing I want to do. I do not want to be told what the step count was. I do not want to be told what the heart rate is. I want to know myself. And that's what I went into when I first came to Google, and they asked me to build, with my team, of course, build a new heart rate algorithm for the Pixel Watch. And the first thing I did was ran off to literature, academic hat on. I thought literature is the way to go. I will have a look. There's loads of stuff on PPG algorithms to heart rate. I can easily just take all of this stuff. But then, over the space of the following few months, I became aware that actually none of these algorithms were quite what they first seemed. So none of them were tested at the kind of scale that was necessary. They would work on a small number of people or for a small number of activities. And the methodologies being applied weren't actually sufficient to support free living. Give you an example, most of the papers I read used 1 to 3 metrics to decide whether the heart rate was good, especially when the ones were comparing A against B. They were sort of saying, oh, we've got MAPE, we've got MAE, we've maybe got RMSE. These are what we're going to do. And these 3 numbers, and then we're going to decide one algorithm is better than the other based on these 1 to 3 numbers. Now, where I am today, where we do all of this stuff in-house and we've built our heart rate algorithm, we can't release or track how good our algorithm is with fewer than about 20 metrics. None of those metrics, well, some of those metrics obviously make it into literature, but the vast majority were not there and still aren't today. So I'm going to take you through a little bit about what I learned around what happens in industry. And I'm going to pick step counting because I haven't done this. So it's not something that I'm actually talking about that exists. I can't give away any secrets, as it were. This is a hypothetical step counter that we want to release for a device. And let's talk about the steps that it would take before I could release this to a consumer device in the Google ecosystem. The number one's a fairly easy one. Got to get some labeled data in the lab. So I'm going to start with controlled walking tests. I'm going to know lots of details. I'm probably going to throw cameras around. I'm going to get all of this detailed data about what was happening to this person as they were walking at this particular time on a whole host of synchronized sensors. And I'm going to pick hundreds of people, not 10. It's going to be hundreds of people, and they're going to be selected for different confounders like height, weight, gender, anything I can think of. That's all in the lab. We're all very familiar with that. I think of that as getting data that I call for a true positive. We know someone is walking. We know what they should be doing. We know the number they should be getting. I think of that labeled loosely as a true positive thing. So that's the first thing we've got to do. And we would do that hundreds of people. Second thing we're going to do, which is probably the thing I would have not done in academia, is to start to gather diverse free living data. And when I say diverse free living data, I do mean both a lot of it, and I mean diverse in the sense of, again, addressing some of these confounders. So different people, I would try to get it across different parts of the world, all of these difficult things that we have to deal with. Hopefully with some ground truth. So maybe I would have an actigraph or something in the case of step counter. I don't want to focus too much on the fact that it is step counting. It's just an example. Now, why is this critical? It's critical for 2 reasons. One is my false negative reason. So the lab data does not capture real walking. And one of the classic things we found at Fitbit was that step counters that were working wonderfully in the lab, etc., were not working at all well when people were pushing a pram or a stroller, depending on where they come from. This was a big problem and continues to be a problem today. It's one of the big challenges for understanding what people's activity is doing. So you would get people having babies and you would be saying, hey, your activity levels have gone down massively. Well, actually, they may not have. It's just that we're not capturing it as much. And there's also what I call a false positive, which is steps can be triggered incorrectly by other real world occurrences. A classic one here was cleaning teeth for us. It turned out that some of the earlier algorithms, when you cleaned your teeth, they managed to generate multiple hundreds of steps. So if you think about that for a second, you start going into your data, you could easily conclude that people who walk just after they get up and just before they go to bed have better oral hygiene. But the reality, of course, is you're just measuring the wrong thing. And this is a mistake in the algorithm. But you need to capture this, and that's really important. It's only at this point that I'd actually go and develop an algorithm. So that's when we sit down, we define a whole load of metrics, again, plural, and we'd apply a whole variety of techniques to try to get the algorithms, stuff from literature, stuff we thought of ourselves, etc., just trying to get something that we can benchmark and say that we trust. Then we deploy to a testing community. This will probably be internal, Googlers in this case, and probably have some sort of scale somewhere, I don't know, somewhere between 500 and 1,000 people is probably likely. And they're going to wear it for many multiple weeks. And we're going to use a feedback cycle where we're changing the algorithm according to their perspective, their feedback. They're going to tell us, hey, I went for this walk and it didn't work as well as I thought it would. And so we have this mechanism by which we're constantly redeveloping things. And we would do that for an absolute minimum of 6 weeks. And to be quite honest, it's much more likely to be in the higher double digits of weeks of testing before. And this is all before it actually got into anyone's hands. Then we get to launch, and then hopefully we launch something. Hopefully it's well received. Everybody is starting to give us some data, which is fantastic. But it doesn't finish there. So then we get to monitoring and improve. So then we're going to monitor all these trends. We're going to look for weird things happening in the data, and we're going to release algorithm updates according to what we see and whether we think there needs to change. So that's quite involved. Takes about a year to do, at least to do all this stuff. And a lot of people will be involved in doing this. And I've left out a bunch of steps. What I realized in academia is not always, but most commonly, the model looks more like this. Go and get some labeled data in the lab, develop an algorithm, and then notional launch, use whatever on your large scale data. And of course, this is not true for everything. Some people get free living data, some people do it at scale. But it is quite hard in academia to do the kind of scale that you see happening in industry. And to be honest, it's only when you've tried all of this data at the scale that you realize just how fragile and difficult it is to do this sort of thing. And so it's quite hard to trust those algorithms. I go back to my earlier point where I was taking heart rate algorithms from literature and coming to the conclusion that actually all of these ones that in the literature were good, they were scoring well. You would look at them and you think, I'd want to use this on my large scale data to make some claims about longevity, etc. But the reality is they didn't work when they got deployed on that kind of scale. And my disclaimer, I am not for a second suggesting that all non-industrial algorithm development is a problem. Of course, some work is fantastic, but a large proportion of it would not meet the bar for commercial launch at the very least. So my new rule is that raw data is only useful for free living studies when you have processing algorithms that have been fully battle hardened. And the challenge for us is battle hardening is difficult. It's much more likely to be done in a proprietary algorithm where there's a lot of money to throw around in industry. Of course, why don't more algorithm evaluation papers get published from industry if they're so good? This is an excellent question and one which I'm trying to address. I think this is something that industry has to change, has to start publishing this stuff and being open about the fact it's done all this level of evaluation and that therefore other people in academia are able to use these algorithms because they feel confident in the way they have been developed. Now, I don't want to suggest that consumer devices are perfect. They're certainly not. We have a whole load of things that don't go well. And I think sometimes researchers who use these consumer devices don't fully realize that some of these things are going to be a problem. But number one, commercial viability is absolutely king. When these things are developed, it is not with an eye to making the absolute best device for collecting the data for you. It just isn't. It's about something that's going to sell. Battery life in particular is incredibly precious, and that results in trade-offs between accuracy and battery life. So sometimes, well, I will be open and say the heart rate algorithm, we could have deployed something that would have been even better than it is on the Pixel Watch, but actually it would have taken more battery, and more battery life is not acceptable from a commercial perspective. Sometimes the aesthetics will trump that specialist functionality that you might look for as a researcher, and you've always got to keep things cheap. And the reality of the commercial world is you've got to have exciting new features to sell the next version. And sometimes that means the focus is put on the exciting new features more than it should be on improving established features. Not always, but sometimes. They're definitely designed for a specific place in the body. So one of the advantages of research devices, as you've seen with things like Activity, you can kind of shove it on any part of the body. You can stick it on a thigh. You can put it on your head if you want. You can put it on your wrist. Those are all great, but pretty much consumer devices are only going to work in one place, and that's the place they were designed for. Certainly when you look at buds, they're really not going to work in any other place than your ear, at least. I'm assuming not. I've never actually tried. Access to all the data streams may not be available. So this is the back of the new Pixel Watch, Pixel Watch 2 that was just announced last week. And the reason I picked this one is because it has a new heart rate sensor where it has 10 different channels of PPG flowing in. And I highlight this not because that's kind of showing off in any way, I don't think it is, but it's because if we wanted to expose that raw data to researchers, we wanted to give you access to the raw PPG, it would cause us a problem because no longer is it 25 hertz from one channel. It's 25 hertz from 10 channels. That's now 250 hertz of data. And that sounds, from an academic perspective, you might shrug and say, well, yeah, that's what I would like. But the reality is that's very difficult to plumb through in a commercial wearable and retain all of your niceties around battery life and performance, etc. So actually, there may be a perspective that, hey, sometimes industry is hiding some of the raw data from us, and I guess that's true in cases. But there's also a reality that sometimes it's just not practical to deliver some of these raw data streams, which is challenging. The other thing that can go wrong is something that I said as a positive a minute ago in the slide, but I'm going to highlight now. We continue to release algorithm updates to address the problems seen in the field. This sounds good. This is something you would want, of course, except that when you've got a multi-year study going, you have to understand that these things will update as consumer devices, and the algorithm might change. And that can be a big problem. Maybe the second half of your data collection is actually more accurate heart rate and you make the wrong conclusions from it. Now, one of the things I'm pushing for, at least in Google, and I hope we get wider in industry, is to have the ability to monitor this sort of thing so that we could at least go and look up, this is the algorithm version that's running on this device at this time. At the moment, that is not possible, but working on it. Takeaway from this section then is consumer devices can address many of the issues that we have with our research devices for large population studies, but it's definitely the case they also introduce new problems for us. And I'm not suggesting that consumer devices should replace all research devices, just merely that there is advantage in both, and then you use them appropriately. But also another takeaway is that as a community, I think we need to focus on how algorithms have been evaluated and tested. And we have to be very, very clear at the bar that we want to set to be able to put things on free living, to make decisions like, I don't know, 9,000 steps is the right number to get. Tooling. Industry definitely has better tooling in my experience. I don't think this is going to shock anybody, particularly as we get to larger data stores. And the previous speaker mentioned this, or started to mention this, on the application of things like deep neural nets to all of these great swathes of data. And big tech does have a significant advantage. Doesn't matter where you sit, big tech is able to move a lot faster on this stuff. And it has a lot of people who work on it, which is a massive advantage over a few PhD students or postdocs. And my example for this one is we've just released workout recognition for Pixel watches as well. And this is an ML model that sits on the device. And I don't want to go into details, but I would just point out that I don't think we could have made this model in academia. The sheer scale of data was the first thing, kind of alluded to that already. But it wasn't just that. It's when you've got many hundreds of thousands of hours of data to process, it's not really practical to do it unless you have the kind of scale that you find in big tech. So yes, Google can crunch that, and then Google can use all its computers, and we were still making this model for something like a week. So it's still a huge amount of data and effort. You take that outside of Google, and the scale drops dramatically in terms of computing resources. And the end result is that that's going to take a really long time to make. And it's very difficult to then go through cycles and improve this thing, sort of iteratively develop something that takes that long. So for workout recognition, great example of something where the scale is important, but also the tooling was important. Now, as an aside there, the model on the watch is good, but there's a much, much bigger non-causal model, which is the sort of thing that I'm trying to get released as a kind of public service in academia. So the purpose we use this for, massive great model, sort of thing you could never squeeze onto a watch, but a huge great model that we were using to pseudo-label our data. So we have hundreds of thousands of hours of people doing stuff, but we didn't know what they were doing. They weren't labeling it for us, or at least when they were, we didn't necessarily trust their labels. But by making a really massive model on the truly trusted labeled data, a smaller subset, then we could apply that to the massive subset to pseudo-label our data and then train off that pseudo-labeled data. And it gave us more accuracy on the true stuff that we knew the answers for. But a nice side effect of this is we've got this massive model that has very high accuracy on activity recognition. Wouldn't that be great if other people were able to apply that to their raw data as well? Takeaway here, studies get larger, data processing needs get greater, and the capability of industry can be a significant help for this. Last point is around large ecosystems. So I said this slide earlier, today we deploy research-grade devices to large numbers of people. The reality is it's kind of large-ish. It's not that large from an industry perspective. If you think about the kind of ecosystem that you have from, I'll take Fitbit as a fairly obvious choice here. There's many millions, I'm not actually allowed to tell you how many, but there is many millions of people across the world, transferring all of this data all the time to a cloud that we can do analysis with. Millions of people, global reach, robust and secure data stores. Don't underestimate that last one, by the way. Often get a lot of stick from people external to industry saying, oh, well, it's not right that these companies should hold our data and stuff. And we can have that argument separately. But one of the things that often comes up is, what if it gets broken into? I would just say that I've never been to a place that has data that's securely held. And I look back at what happened in academia now and I wince, because the ease with which it could be broken or stolen is quite scary. But in Google, things are locked down. There are also problems with this approach, though. We can't just use this massive ecosystem and assume everything's going to drop out for us. We're definitely going to get a biased population. Certain people will buy certain watches. And then we have heterogeneous devices, which is a problem for us as well, because not all devices are going to be the same and behave the same, and we have to deal with that. And again, we have no trusted health labels in this cloud. It's not like people are telling us this is what my doctor medical records say. So the takeaway from this is that I think commercial ecosystems have truly large data, connected longitudinal, but they lack all that full health insight. And there's a massive opportunity here, not for industry to take over, not for academia to take over, but to collaborate together to make something that meets all of the things that we want to do and to make people generally healthier. Okay, I'm running out of time, so I'm going to go to my closing remarks. 2 quick slides, really. I think the key takeaways are this. The population research would benefit from closer industrial academic ties. I am not saying it should be either way. I'm saying we should fuse them together. Consumer devices should be very seriously considered for large-scale, long-duration studies. But again, they're not necessarily the right choice, just that they should give them good consideration. And we should find a way of making use of these consumer ecosystems, because they could provide ready-made, extremely large populations, not in the hundreds of thousands, but in the millions. What do we need to do? Lots. There's loads of work to be done, but I highlighted the ones that I think are most important at the moment. One is to find new engagement models between academia and industry. I have spent the last year trying to make all sorts of different connections with and contracts with between academia and industry. And it has not been easy. Some of you are on this call who have been doing it with. It has certainly not been an easy thing to do. And very often the sticking point is the perspective of academia rather than the perspective of industry. And I say that both with an academic and industrial hat on. From an industry perspective, we need to start making available offline algorithms for research use. We need to make this encourageable. And we need to get this stuff published, so the quality of the ones that are released are fully known and you can all refer back to. I can talk a little bit in the questions if you want about why I think that's challenging. And then from an academia perspective, again, I think we need to review our algorithms and our valuation methodologies to be quite confident that we are doing the best we possibly can. Right. I think you've heard more than enough from me. I would be delighted to hear from all of you. And if you feel like you want to correct my perspectives and thoughts, then even better, because that's always good to have. So please do reach out to me at any of my emails. I've put the Google one on here because these are Google slides, but I would love to hear more. And if there is time for questions, I would love to take some questions. Thank you very much.
Fantastic. Thank you very much, Rob. Fascinating, I think, for us to hear, as a group, largely from an academic background, some of the perspectives and processes involved in developing systems to capture, I guess, the behaviors we're all interested in, with kind of a commercial perspective. We have got a number of questions, and I think what I'm going to do is I'll probably extend the session slightly, because I think it will be great to hear your view on some of these. The first question is around, you mentioned the large kind of data ecosystem, the massive amount of data that's held by commercial organizations. There's a question around whether it's possible within kind of collaborations between academia and industry for that data to be accessed for research purposes. Is that possible? How is it possible? Are there limitations in that?
Yes, and it's a funny answer, this one, because it's actually made harder by some of the EU rules, which is unfortunate. That was not their intention when you may recall that when Fitbit was absorbed by Google, the EU was not happy with it for competitive reasons, perfectly reasonable points, and put a lot of constraints on what could happen to the data and how it can be shared, etc. Now, none of those constraints are meant to stop working with research, but the reality is that it can be quite challenging to meet all of the things that are required. But to answer the question a little bit more directly, yes. Well, so first of all, I can only speak for Google Fitbit side of things. I obviously can't speak for anybody else in the industry. Is it possible? Yes, I think it is possible to find a way. We need to find new ways of doing this, but there are different approaches to this. Can people just get access to it straight away? no, it's not as simple as that. I think it would be around doing co-analysis of certain bits of data. And we would have great difficulty in bringing that data outside of Google, I think, mainly because, again, we have these legal commitments to how the data is processed and controlled, which are extremely stringent. So I think the likely way in which we can work together for analyzing that is to have like a research proposal to run on the data and to work on it collaboratively. And my group is certainly interested in that, in doing that kind of thing. I am also trying to get to a stage where we will get effectively the ability to people can put proposals in essentially, and we can try to work together to make that done. I can be honest and say that has not happened yet, but that is something that is hopefully going to happen soon. But we are in a situation where the data has now come into Google. 3 years since Fitbit was absorbed, and 3 years on, we are still not in a position where all the data has come into full Google servers. And I mention that simply because until it is, it's very hard for us to control what's going on. So yes, I think there are ways that we can do this, and I hope there are more of these. And I very much hope I'm not wrong.
Thanks, Rob. I've got a question that feels a bit linked to this one. This is from Mark. Welcome, Mark. You mentioned in your talk the need for, in kind of establishing these collaborations between industry and academia, the need for at times perhaps a change of perspective in academia and working with industry. Could you say more about the specifics of change of perspective might be needed?
Yeah. So there's a couple of things that are interesting here, I think. One is there is at least in the European academic perspective is that, oh, well, if the university does something, it needs to own all the data, and it needs to basically have a big slice of the pie and anything that gets commercialized, etc. That's understandably quite difficult from a commercial perspective. And we need to be able to have a little bit more flexibility to think how this is going to work. So as an example, one of the things I'm working on at the moment, we are hoping to do a large scale study. I won't go into too many details, but it would be the first time that all the raw data would be released, and it would be released publicly. So the data would be allowed to be owned by the university. But at the same time, Google needs the ability to use that data to do some commercial things. And that's just the reality of the world. But everyone benefits from this. So there's a commercial algorithm, but all of the data that it's produced from would then become public. And that's not something that's, as I say, has ever happened before. So it needs a bit of flexibility from the university side for understanding that it's not a case that the university needs to own everything and have everything, which is typically the position that universities start from. The second part that is more interesting, and something that surprised me slightly, there are things we can do in academia that would help industry to publish some of this stuff. I said that we need to get industry doing more of this publication. One of the barriers to it, surprisingly, is industry typically only wants to publish in high profile venues. That makes a lot of sense. And then equally, what we've got at the moment are sensible pushes in academia that when you release a paper, you should also release the data. Makes a huge amount of sense from an academic perspective. But what I've learned is the practicality of that is that turns industry off. So they start to look at it and say, well, we can't publish this because they'll insist on us, or we're going to have some sort of legal meeting about what data we can release. And we don't think we can release the data, and we don't want to be going down that path anyway, because it's, we feel we would betraying the trust of our users if we were to release this data, even in an anonymized form. And that's not something that I was expecting to see coming from an academic background, right? I always massive supporter of, yes, we should release the data. Everyone should be able to do the same analysis. I completely understand that perspective, but the reality is what's happening is that they're not getting published because of it. So there are sorts of interesting things we can do from academic perspective. And I think universities need to just have a little bit more flexible approach when they think about how they would interact with industry. And I will just point out that I deliberately singled out European academia earlier, because in the US in particular, and some other parts of the world, we're seeing a lot more flexibility. And what's happening is we can set up those collaborations a lot easier. And I don't want that to happen, right? I don't want us to be left behind in Europe.
Thanks, Rob. I'm going to pose one more question, and apologies to everyone who's put questions in the chat, because we have lots and lots. So I would encourage you to get in touch with Rob. The question is actually building on one from a previous session from Fiona Bull, who's here representing the World Health Organization. Fiona announced one of the questions earlier that the WHO is commencing work to review and develop updated global guidance on the measurement of physical activity. So Fiona's asked for your view on the possible role of industry in supporting and informing WHO to develop guidance for countries on the use of wearables for physical activity measurement. What you envisage the role of industry could be in supporting that, given the data capacity and the kind of global scale of the sector.
Well, that's a great question. And actually, we've worked with WHO before to do various things on physical activity. So one answer would be to reignite some of those conversations. But yeah, what can the role of industry be? Well, I think industry wants to be around the table for some of that, not just industry. It needs to be all parties. But I think having the right people there at that table, having discussions around what devices could be used, how we could do, in fact, all the stuff that I've just been talking about, it would be great to have an incentive for the WHO to say something like, well, we want to do this thing and we want the algorithm evaluations published. Those kind of things are actually very forceful for our industry, because industry would like to be able to say something like, hey, the WHO approves or at least agrees with the algorithms that we're using in this commercial thing. So I think, is there an easy way to incentivize industry to come in? I appreciate that question was more, what role can industry play? I think you just need those voices around there, because you're not necessarily seeing all the things that are happening behind closed doors, all of that large big tech, etc., all of the large models, etc. I think those need to come to the forefront and they need to be discussed, and people need to understand how we're going to put together all of this stuff. And another thing I would add is that what we're seeing now with the current boom in AI and LLMs, etc., ChatGPT, etc., there's huge opportunities for intervention and coaching there. And that is something that I think would be a very good thing to have discussed in WHO and as those kind of physical activity guidelines, etc. That would be a very important thing to incorporate. And the reality is, no non-commercial entity is in a position to be creating those models. They can use them, but no one is current, other than the really large big tech, is in a position to actually make these things. These things take many months to just crunching of huge amounts of data and huge amounts of computing power. So if you don't have them around the table, then you're going to miss out on all of that stuff.
Brilliant. Thank you, Rob. Apologies again to everyone who's asked lots and lots of questions. I will encourage you to contact Rob by the methods he mentioned.
Yeah.
I'll close the session there. I think you'll join me, everyone, in thanking Rob once again for a fantastic talk. We're now going to move into a very short break before we move